and welcome to today's Galbraith conversation. Delighted to be bringing you some really exciting guests this afternoon, the first of which is Virginia Hogan. She's from Dymax Corporation. Welcome, Virginia. Nice to see you.
Thank you so much to have us.
Yeah. So
Appreciate
you're here to talk about a rather exciting staking material, which is, I guess, an underfill, but used for low-orbit space applications.
Yes, that's exactly it. It is called Dymax 9773. We develop it to meet a gap in the market for low ionic content, low outgassing that are used on spacecraft, missiles, as well as on satellites. And the demand in the industry has been unmet for many, many years. They grandfathered in other materials that didn't meet the requirements of the MIL Standard 883.
Right.
In talking with a lot of the OEMs, every time we ask, okay, what are the product gaps in the market, this repeatedly came up. So we went back and we worked with our R&D group to be able to design something that met all of these requirements. And they're very stringent requirements because you think about it, it's going to be used in a space application. They put a satellite up into space for 3 to 5 years. It's not like they can go and repair it.
No.
They can't bring it back home. It's up there and that's it.
It's got to work.
So it's got to work.
So,
and that's why the requirements are so stringent, because they have to continuously function. It's not like they're using it only for an hour a day. This is continuous for 5 to even more years.
Right.
So we were able to develop a material, and it's a light curable material versus an epoxy, cures in seconds. So they don't have to wait and rack it and wait for it to cure before they can move it on to the next application. So it's immediately available. In the staking material, what it does is it ruggedizes capacitors on the board, so that with the vibration of the movement of whether it's a launch vehicle or a satellite or a missile, this material allows that capacitor to still stay connected to the board, that you don't break that connection.
So does it have an elastometer built into it so that it gives it some pliability?
It does. It has an elongation measurement of about 85%. So it's flexible, it's not rigid, it won't break, but it absorbs that energy so that the capacitor will stay in place.
Right. So what are some of the thermal excursions it's going to experience?
So what it has to do is it has to survive minus 65 C to 125 C. Those are the operating temperatures that you've got to test the reliability under those conditions. And this material meets all of that.
Meets all of that, right.
So it works for the low Earth orbit satellites.
Right.
It doesn't meet the requirements for a geo satellite, which are cryogenic temperatures, but it meets the LEO satellite requirements.
Right, absolutely. So when you say it's a staking material, it literally goes up the height of the capacitor.
That's correct.
And covers the whole side of the
so you would
device.
apply a bead from the top of the capacitor down to the printed circuit board, and you would do it in multiple locations depending on the height and the diameter of the capacitor as to whether you need just 2 beads to hold it in place or 3 or 4. The material also could be used as an encapsulant to protect boards, because it is moisture resistant as well as it is corrosion resistant.
Okay.
But the only challenge with this, to have a material that meets this low ionic content, it is a very heavy material. The density is high. So in some BGAs, if you were going to use it for an encapsulant or other smaller components on the board, you have to make sure that it's not fine gold wires, because the pure weight of the material under those conditions, it could break.
It could break them.
So you have to, we would recommend it as a ruggedizing material, but it could be used as an encapsulant in certain circumstances.
Right. Well, it's certainly in a very topical area at the moment. What other types of materials is Dymax making for these types of applications?
We have another material that meets these same kind of requirements. It's Dymax 9771, which is a conformal coating. So that protects the entire board. And it also meets the low outgassing, the low ionic content, as well as having a UL94 V0 rating, the flammability rating, and meets the MIL I46058 conformal coating standard.
Okay.
So it meets all of those electrical requirements, the thermal requirements, and meets all of the needs, as well as it has flight heritage. So
Right.
both of these materials have been on satellites since November of 23. Just
Okay.
again proving the credibility of these two new materials.
Right,
To
so they're actually being used in theatre right now. And,
Yeah, absolutely, yeah.
Excellent, excellent. Well, that's really interesting and really exciting material. What other applications do you think it could be used for outside of space?
Well, you think about on consumer electronics. As the boards are getting smaller and smaller, they're trying to cram more intelligence into these phones and into the consumer electronics, or whether it is a wearable device. They have to look for materials that are also low outgassing, because you can't redeposit on the functionality, even though they have a life that's maybe 2 years. But low outgassing is becoming more and more a critical feature in conformal coatings and in ruggedizing materials on just about every type of electronics.
Yeah, absolutely, absolutely. Well, it
Ladies and gentlemen, please join us.
certainly sounds like an interesting material,
Yeah.
Virginia.
Thank you very much.
And I want to. We're getting interrupted a little bit here, but I want to thank you very much for coming in and telling us about it today.
Thank you so much for this opportunity.